Hello, in this last video, we are just going to introduce some terminology we can use for sequences. And this terminology is very similar to terminology that either just makes sense by the wording or has probably been heard in some ways before. So a sequence is increasing if a sub n plus 1 is greater than a sub n for all n. This means for every n, I know the next term is bigger than the one before it. Non-decreasing means they could stay the same. It's increasing, or maybe a sub n plus 1 is the same as a sub n. So this could be like, the top one would be like 1, 2, 3, 4, 5, and so on. The numbers keep going up, they never stay the same. Non-increasing could be the sequence 1, 1, 2, 2, 3, 3. The values go up, or they stay the same, they just don't go down. Decreasing is then the reverse. A sub n plus 1 is always smaller than a sub n for all n. And it's a strict decrease. So -1, -2, -3, -4, and so on. Non-increasing just could stay the same, could decrease, just doesn't increase. -1, -1, -2, -2, -3, -3, and so on. Monotonic is the word that's used for it is one or the other, meaning a sub n is either non-increasing or non-decreasing. Sometimes we don't care if it's increasing or decreasing. We just care it's only moving in one direction. Bounded above means there exists some number m such that a sub n is less than or equal to m for all n. This is like how sine is always less than 1, less than or equal to 1. Since sine n is always less than or equal to 1, sine is bounded above by 1. Bounded below means there exists an m such that a sub n is greater than that value m for all n. Using sine again, sine is always bigger than -1. So sine is bounded below by -1. And then bounded just means it is bounded above and below. Surprise, surprise. Sine is bounded. It is bounded below and it is bounded above. So sine is bounded, cosine is bounded. And these theorems give us a property altogether that we have generally seen in some cases, but it hasn't been pointed out. It is known as the monotonic sequence theorem. The monotonic sequence theorem says that every bounded monotonic sequence is convergent. So taking those words together, there's a bunch of terminology that just got introduced. Bounded means there's some value that the sequence is always smaller than, and another value that it's always bigger than. Here's my upper bound. And here's my lower bound, and my sequence will not pass these bounds. Just won't. Monotonic means it only moves in one direction. Could only increase and maybe stay the same, or it could only decrease and maybe stay the same. Since it only moves in one direction, I'm going to pick one of those to sketch. I'm going to say, suppose it is monotonically increasing, so it never decreases. Then my sequence, being monotonically increasing, means it can only increase, can maybe stay the same, but ultimately can only stay the same or increase. But that upper bound means I can't go past that upper bound. And since I can't turn around, I am stuck at that upper bound. Therefore, since I'm stuck at that upper bound, I have a limit. Since my sequence has a limit, it is convergent. So just putting these words together gives us this new theorem. And there is all of our new terminology that we will use as we continue into series, which are sums of sequences that might have certain properties.